Continuity and behavior and limits. The objective of this video is to use limits to determine the continuity of a function. So continuity is basically you have a function on a graph and there are no spaces. You can take your pencil and trace the entire function without lifting it up. So types of discontinuity are a jump where you are basically continuous and then all of a sudden you have to jump your pencil to continue the graph. A removable discontinuity is basically you just have one point where your function is undefined. And an infinite discontinuity is basically your graph is going towards infinity in either directions. So in order to identify the types of discontinuity, you basically have to look at a limit. And you're basically just looking at your graph to see what happens as you're approaching either side towards a number. So in order to determine whether something is continuous or not, there is a continuity test which has three parts. The first part is to determine whether the function exists at a given number for x. So if I want to determine whether this function is continuous at x equals to 0, I will replace the value of x with the number 2 to determine if I have a number. So f of 2 is going to equal 2. X now becomes 2 squared minus 3, 2 minus 1. So 8 minus 6 minus 1. So 2 minus 1 equals 1. So I do get a number. So f of 2 exists and it's equal to 1. So f of 2 is equal to 1. Then I need to find the limit f of x. In order to determine that, I am going to analyze the graph looking at a table. So I want to create a table where 2 is the center, and I want to determine what is happening to the left and to the right. Now, a limit is looking at basically what is happening as you're infinitely going towards this number. So you're looking at the itty-bitty numbers. So itty-bitty numbers to the right will be, so we have 2.001, 2.01, 2.1, and then 1.999, 1.99, 1.9. So this will be my x values. I will find my y values using a graphing calculator. So we get 0.52, 0.9502, 0.995. We don't really care what's happening here. And then 1.005, 1.0502, and 1.05. Oops. And 1.52. So then you're going to expect this table from the left and to the right. So as we are going towards the right, we are getting closer and closer to the number 1. And as we're going to the left, we are getting closer and closer to the number 1. This means the limit of f of x as x approaches 2 exists and it is equal to 1. The third part of the test is to determine whether my two statements are equal to each other. So f of 2 is equal to 1, and the limit of f of x is also equal to 1. Because the statement is true, f of x is continuous at x equals 2. Now you want to determine whether each function is continuous at x equals 0. Pause your video, press play when you're done to see if your answers are correct. Pause your video now. So my f of 0 is going to actually equal 0. And then for my table, I am actually getting very itty-bitty numbers So I am going towards the left as I'm going towards the right. I'm getting closer and closer to 0. Again, I'm getting closer and closer to 0. So that means that the limit f of x as x approaches 0 exists and it is equal to 0. Then you want to analyze whether the two statements are true. So f of 0 is equal to 0 and the limit of f of x is equal to 0. They are both the same. So f of x is continuous at x equals 0. For the second question, my f of 0 is equal to 0, but now when I'm analyzing my table, towards the right, I'm getting closer to negative infinity because my numbers are having big jumps. But in my other side, I am getting closer to the number 0. Because the limit does not exist, meaning we're not approaching the same number from both sides, this means the function is discontinuous. And because we are approaching two different numbers, we can actually say that this is a jump in discontinuity. Now you try. Pause your video, try and do this problem, and then press play to see if your answer is correct. Pause your video now. So when we plug in 2 into our function, we get an output of 0. And then when we're analyzing to the left and to the right of 2, because that is the point of the question, x equals 2, we are approaching 0 and 15, which are two different numbers. So the limit of f of x as x approaches 2 does not exist. And it is going to two different numbers. So this means that there is a jump in this continuity. So it is discontinuous because it failed one of the tests, and it means jump in this continuity. We can also approximate zeros by looking at what's happening in between certain intervals. So in order to do this, I'm going to use my graphing calculator, and I am going to determine what is happening in between the interval -4 and +4. So from -4 to -3, it stays negative, so there is no change. However, from -3 to -2, there is a change in sign. We are going from a negative number to a positive number. So this means there is a possible 0 in between this interval. So again, we are no change, but then from 0 to 1, we're going from a positive number to a negative number. So there's another change in sign. So this indicates another possible 0. So from 0 to 1. And then again, from 1 to 2, there's another change in sign because we're going from -1 to +2. So that is another interval of a 0. And then everything else stays the same sign. So using this idea, this makes sense because if we were to graph this function, we would see some zeros in between these numbers. However, because it's not going to be exact, we are using this method to determine that there are zeros present in between these numbers. So there are 3 possible zeros. So now you try, determine between which consecutive integers the real zeros of each function are located on the given interval. Pause your video, try and do this problem, and then press play to see if your answer is correct. Pause your video now. For this first problem, there is no change in sign. However, between the interval -1 and 0, we are getting very, very close to the number 0. So this could mean that in between those numbers, there is actually a 0 somewhere. So we're going to include this as one of the possible ways we can determine if there is a real 0 between the intervals. So for the second problem, when we're analyzing our table, there is a change in sign from -3 to -2. And there is a sign from 2 to 3. So those two intervals will determine a possible solution or possible 0.